Hi, my name is Matthew Pathiel. Today we will be discussing some concepts behind data analysis and the several steps needed to take in the data analysis process. So what exactly is data analysis? Data analysis is the process of inspecting, cleaning, transforming, and modeling data with the goal of discovering useful information, suggesting conclusions, and supporting decision making. The use of data analysis has been around since ancient times. However, the rise of computer and internet allowed for data analysis to be incorporated in the electronic computing industry. There are several phases included in the processes of data analysis, such as data requirements, data collection, data processing, data cleaning, exploratory data analysis, modeling and algorithms, data product, and communication. Under data requirements, data must be specific to the needs of the person doing the analysis or the user of the final product of the analysis. There are two types of data that can be collected: quantitative data and qualitative data. But what are the differences between the two? Quantitative data indicates anything that can be measured numerically, such as your foot size, your height, etc., whereas qualitative data is more descriptive and includes things that are harder to measure, such as color, race, gender, etc. The second phase of data analysis is data collection. Data collection can be conducted from a plethora of sources. Collection can be conducted internally from the drivers of the analysis or from outside vendors such as traffic cameras, satellites, and recording devices. The third phase is data processing. Processes of data analysis depend on taking data in its entirety and breaking it down into simpler components for observation. These processes also allow for raw data to be obtained and converted into information useful for decision-making users. Some areas where we see this growing is with commercial data processing, which involves large volumes of input data, relatively few computational operations, and a large volume of output. Packages like SPSS or SAS are used to help aid this. After data processing has been completed, the data must be cleaned of incomplete, duplicated, or data that is errored. Some methods to clean data include record matching, deduplication, and column segmentation. The exploratory data analysis phase can now be conducted to decipher any messages encoded in the data. Descriptive statistics such as average or median help measure data in this way. As a result, data is modeled and applied to algorithms to seek variable relationships such as causation and correlation. Inferential statistics include techniques to measure these types of relationships between particular variables. Once a model or algorithm is created, a final data product can be issued that takes the data inputs and turns them into outputs. In this final phase of data analysis, the analyst will utilize methods using data visualization to communicate the data to the users of the final product. One way to communicate data is with data visualization. Data visualization uses information displays such as tables and charts to help communicate key messages contained in data. Within data analysis, there are subcategories including data analytics, data mining, and cognitive computing. Data analytics is the discovery and communication of meaningful patterns in data. Its focus is on inference, the process of deriving a conclusion based solely on what is already known by the researcher. Analytics also relies on data visualization more and includes a variety of disciplines. Sectors of analytics include risk, digital, security, and software analytics. Another faction of data analysis is data mining. Data mining is the computational process of discovering patterns in large data sets. and utilizing methods of artificial intelligence, machine learning, statistics, and database systems. Data mining extracts this data and transforms it for better comprehension. In history, similar terms have been used to describe this concept, such as data fishing or data dredging. The last subcategory is cognitive computing. Cognitive computing takes human problems and apply them to computing. Cognitive computing must be adaptive, interactive, iterative, and stateful and contextual in order to be achieved. If it's to be adaptive, it must learn as information changes and as goals and requirements evolve. For cognitive computing to be interactive, it must interact easily with users so that users can define their needs comfortably. They may also interact with other processors, devices, and cloud services. Being iterative and stateful means that it must aid in defining a problem by asking questions or finding additional source inputs if a problem statement is ambiguous or incomplete. Finally, the information must be contextual. They must understand why and identify and extract contextual elements such as meaning, syntax, time, location, etc. So what does this all implicate for the future? The data analysis is evolving business intelligence and the way corporations operate. Internet databases with variable and data set ontologies are continuing to rise and will take the IT realm by storm.